Well, hello there, it's Mr. Doro. Today I'm going to be talking to you about scientific notation and how we can use it and what the correct number of sig figs to. So let's go. Well, first of all, we have to start with a rule for scientific notation. The rule is that when you're writing a number in scientific notation, there can only be one digit before the decimal, and it can't be a zero. So if you look at this first number that I have, this 45,000 right here, there's no decimal in it, but you know that the decimal would be right there. And so the decimal we have to move the decimal so that there's only one digit in front of it. The only place that we can do that on here is to move it to this place right here between the 4 and the 5. Any other place we move it, if we moved it over here to where right here between the 5 and the 0, there's two digits in front of it. So we have to move the digit over, and so moving that digit over, we would call this one now 4.5. We'll talk about in a few minutes whether we need to use those zeros or not. But then we say times 10 to the, and then we count how many spots we moved it over. We moved it from here, 1, 2, 3, 4 spots. So times 10 to the 4th. The question always comes up, is it positive 4 or is it negative 4? Well, the way I always remember it is that if that number that we started with, this 45,000 right here, if that number was bigger than 1, then it's going to be a positive 4. If the number was smaller than 1, it'd be negative. So let's take a look at this next one. The next one, the only place that we can move the decimal so that there's only one number in front of it and it's not a 0 is right there between the 1 and the 6. So we count how many spots we had to move it over. 1, 2, 3, 4, 5 spots. Did I count that right? 1, 2, 3, 4, yep, 5 spots. So this one would be 1.6. I'm going to put the 0 on there. We'll see why in a couple minutes. Times 10 to the, and now we moved it 5 spots. I'm going to put a 5, but that starting number was smaller than 0, so it's times 10 to the negative 5th. So now we can practice on a couple. We got this number 3521, and so the decimal on this would be after the 1. We have to move it over to where? Where? That's right, in between the 3 and the 5. So this is going to be 3.521, and then we're going to put times 10 because we moved it. So times 10 to the, what is it? What is it? The third, positive 3. This one, we'd move the decimal to right here between the 2 and the 1. So this is going to be 2.16 times 10 to the, negative third. There you go. Well, then I wonder how we're going to figure out how many significant figures to put in for scientific notation. The rule is this, that you only put significant figures in before the times 10, but you put all the significant figures in there. So if we look at this first one, 9,500, what are the significant figures? Do the zeros at the end count? Well, no, the zeros at the end don't count because there's no decimal, so the only significant figures are this 9 and the 5. And so when you write this, you would not write the zeros on there. You would write 9.5 times 10 to the third. And that's in scientific notation for the sig figs. By the way, scientific notation is SN, capital S, capital N, when we write it out. This one, they're all significant, so we have to include them all. This would be 9.5000, and then we count how many places we moved the decimal over. Not from the end, but from the decimal. We went 1, 2, 3 places, so times 10 to the third again. This one, these are all significant, so we would put 9.05. Whoops, that's a 5, believe it or not. Times 10 to the second. And this last one right here, they're all significant again. We would put 9.050. We include all significant digits in there. Times 10 to the second on that one. Well, here we have some more practice, and these ones we have to look at the significant digits also. If you look at this first number, remember the significant digits or sig figs don't start until you get to the first non-zero number. There are your sig figs. So this one is going to be 2.05. I dropped off all those other 2's times 10 to the, and then we moved it 1, 2, 3 spots, negative third. This one, there's my sig figs. That 0 at the end counts because there is a decimal in the problem. We don't start counting the first till the first non-zero number. And so I moved it 2 spots over, so this is going to be 2.50 times 10 to the negative second. This one, here are my sig figs that have to go in scientific notation. 2.5000. You know, sometimes people stop right there and they say, let's just call it 2.5000. But that's not representative of that number. You have to say how far you moved the decimal, and we moved it 2 spots, times 10 to the negative second. This is one like we did on the last slide, and this is the only sig figs are the 2 and the 5. So we go 2.5 times 10 to the third in this case. These are all significant, so we would say 2.050 times 10 to the second. Well, then we have one last thing, because sometimes you'll be given scientific notation, and maybe you're asked to change it back into decimal notation. So that can be a little tricky sometimes, so that's why I wanted to go over it right now. This is 6.02 times 10 to the fourth. That's a positive 4, so we know that our ending number has to be bigger than 1. And so we know that we're going to end up moving the decimal this way, 1, 2, 3, 4 places over this way. And then we drop the times 10, so we go 6, 0, 2, 0, 0. When we do that, I moved the decimal over 4 places, and I filled in with zeros anything that I didn't have. This is 2.31 times 10 to the negative third. Negative means that the number's got to be smaller than 1, so we got to move this way 3 places. So this is going to be 0 point. And then 1, 2. A lot of people many times put 3 zeros in there, but it's just the 2 zeros and then the 2. That means you moved it over 3 places. 3, 1. And then same thing with this one. We need to move it back to the left 4 places, and so we get 0 point, and then 3 zeros in the 8, because, and I'll prove that to you. Oh, those zeros are important though too. I'll prove that to you right now. Look at how far we moved it. 1, 2, 3, 4 places there. Don't get caught up thinking that means 4 zeros that you put in there. And then that last one, 3 times 10 to the 8th. That's positive, so it's going to be bigger than 1. So we have 3, and then 1, 2, 3, 4, 5, 6, 7, 8 in this case, which would be a big number, 300 million. I hope this really helps you out. Have a great day. Bye-bye.